Today we start talking about a new concept, which is the ability to store massive amounts of data in memory and to organize that data, which is often related in some way. And the data structure that is going to allow us to do this is something called an array. So over the next couple lectures, we're going to be talking about a number of features of arrays. Today is going to be all about introducing arrays, and then the next lecture will talk about arrays and functions, programming with arrays, and multidimensional arrays. So as I said at the outset, what we wish to do is store large data sets, large related data sets. So we might want to store a photo which has thousands of pixels, or a file for a word processor which may have thousands of lines, and we may want to store each of the lines. Or we may want to keep track of our weight. Maybe we're dieting and we want to keep a moving average of our weight. Say the last 7 weights, we want to keep an average of our last 7 weights. Well, as you might imagine, it could be very difficult to store such large quantities of data using the tools we've seen thus far in the course. For example, with a photo that had 1,000,000 pixels, might have to define 1,000,000 variables, starting with, say, pixel 1, pixel 2, pixel 3, pixel 4. And you can imagine what a nightmare it would be to deal, first of all, with a program that had 1,000,000 variables. Think how long it would take you just to declare that many variables, much less do anything useful with them. So we'd like to have a way that, in effect, we could store these 1,000,000 pixels, but have a more efficient way of referring to them syntactically. And the way we do that is with something called an array. So an array allows us, with a single variable name, to store a collection of related data. Now here I've stored 7 temperatures, and we use indices starting at 0 to index into the temperature array. So this temperature array, again, is storing 7 elements. Think of them as the last 7 days temperatures. So again, the indices start at 0. So at location 0, we're storing 83. Location 1, we're storing 67. Location 6, we're storing 92. And we could do this with pixels too. We could have an array of pixels, declare it to be 1,000,000 elements, and it would be addressed using the indices 0 to 999,000. We'll see the syntax for accessing these elements in just a moment. So again, an array is a collection of data of the same data type. Later in the semester, we'll show you how to group heterogeneous data together, such as information on a driver's license, which has disparate types like strings and numbers. But here we're talking about data all of the same type, say all ints or all strings. And here's an example declaration for an array. So you give the type of the data that it's storing, in this case a double, the name of the array, and then in the number of elements enclosed in square brackets. And this is the general form of an array, so it looks just like a variable declaration. The only change is now you have this additional element which specifies the number of elements stored in the array. So here's some example code using an array, and in it you'll also see how we access elements of an array. So we want to record and then print out the temperature from the last 7 days. So we first declare an array of temperatures and say it has 7 elements. Then day is simply going to be a counter variable that allows us to count to 7. Now we're going to use a for loop to read our temperatures into our array. So we use a counting loop, a for loop. So we're going to read 7 values, hence we're going to have a loop variable or counter variable that goes from 0 up to 6. Remember that array indexing starts at 0, so in fact with 7 elements it goes from 0 to 6. And we prompt them to enter the day, or we say enter the temperature from, say, 1 day ago. And then here you can see we read it into the array, and you can see how we syntactically specify which element we want to place the value into. So we do it by giving the array name and then in brackets the index location where we want to store the item. So the first time through this loop, day is equal to 0, so we're saying we want the program to store the value at the 0th location of temperatures. The second time through the loop, the value of day is 1, so we'd be saying put it at index location 1, and so on. And then here we're simply printing out those recorded temperatures. And again, when we print it out right here, we print out or say which element in the temperatures array we want by specifying an appropriate index value, again enclosed in square brackets. So we've been talking about indices, and that is how we access elements in our array. So remember at the outset of the lecture I said it'd be very inconvenient to have to declare a million variables named, say, pixel 1, pixel 2, pixel 3. So an array solves this problem. It does in effect allow us to have a million elements, or for a temperature 7 elements, but we just declare one variable, in this case temperature, and then we can refer to the individual elements with indices. And again, the rules for all arrays, the smallest index starts at 0. This is true of all C++ arrays. And because our arrays indices start at 0, the largest index is always 1 less than the number of elements in the array. So with temperatures, there were 7 elements. The first element was at location 0. The last element is at location 6. Okay, so let's just do a demo for a couple of the concepts we've been discussing. First, let's say we have want to store 23 scores. How would we do it? Well, let's declare an array, and it's going to be an int array because it said of type int, and we said we want it to be named scores, and finally it's supposed to have 23 elements, so that would be the declaration. So our second thing is saying assign the last element of an array named weights to a variable named x, and we're to assume that weight has 10 elements. Okay, should have said weights here. So we're going to assign it to a variable named x, so we're going to say x equals, our name of our array is weights, and we said we want to assign the last element of weights, and we said it had 10 elements. Well, remember our rule is that the largest index is the number of elements minus 1. So in fact, the last element is located at index location 9, and this is the statement, x equal weights 9. Okay, so here's another demo. Let's say that we have an array of parts. As you can see, it has 6 elements here, and we have 2 integer variables, I and j, and we want to write some code that swaps the values of parts I and parts j. So for example, if let's say we had I equals 1, let's say j was equal 4, then what we're looking to do is swap door, which is entry 1 here, with AC, which is entry 4. So to do that, we need to start by declaring an additional variable temp. And now we can store into temp parts I. So in this case, if I was 1, we would have temp was now equal to door. And now we want to set parts I to be equal to parts j. So this means now that parts I, which is going to be equal to AC because we said that j was equal to 4. And finally, we assign to parts j the value of temp. So now parts j is going to be equal to whatever temp was, which is door. And you should see that we've now successfully swapped the two elements of the parts array. Okay, so now segueing to a slightly different part of arrays, which is so far when we've declared an array, we've used constants, right? Hard-coded constants. So here, to declare an array of 23 elements, we said int scores 23. But in general, that's a bad idea to hard-code the constant, and that is because the size of the array is going to appear in many places in the code. And so we prefer to use constant variables to declare array sizes. So here's my same code from before that read temperatures into a temperatures array and then prints them out. The only difference is I now have declared this constant variable named numDays. And in red, I've highlighted the 3 different places in the code where numDays appears. So first of all, I use it in my declaration of an array to say how many elements it has. Then I use it in my first for loop that reads the number of, or that reads temperatures into the temperature array. And then I use it in my loop that prints the recorded temperatures. And while this piece of code only has 3 references to the size of the array, a big program like Adobe Photoshop that is processing a photo array might need to have hundreds of references to the size of the array. And you can imagine the heartache you might have if your boss came in and said, we just discovered the array's not big enough. We need to change it from 7 pixels to 1,000,000 pixels. And you're like, oh my gosh, I hard-coded 7 all over my program, and now I need to find all those instances and replace it with 1,000,000. And it would have been so much simpler if you just in one place, you'd said, in this case, const say int num pixels, and you could just change it from 7 to 1,000,000, and you would have changed it in one place, and the change would have been reflected in all other parts of your code. So try to get into the habit of using constants to declare your array sizes and also to refer to the size of an array. Now, you're going to get a lot of practice using for loops in the next couple weeks because loops and arrays go hand in hand with each other. For loops are the perfect mechanism for iterating through an array because they essentially have counter variables and they allow us to sequentially traverse through an array, which is a very common operation. So the code you see here is actually just the code you've seen throughout this lecture. It's a for loop that reads the temperatures into this array. So here we have an exercise involving an array, and we're going to find the minimum value in an array. You'll see in a moment how we initialize arrays using an initialization list like this. It's a comma-separated list of values between curly braces. Obviously, you've seen another way, which is to read values into the array using cin. And at any rate, we've initialized grades to these 5 values, and we're assigning the minimum value to grades or to min, so that's 80 because that's index location 0 in grades is 80. So now we're going to start our iteration at 1. I could have started it at 0, but that's pretty useless or a waste of time because I already put the 0th index, the value of the 0th index location into min. So I should start at 1. Going to iterate up to but not including 5 because if you look over here, you can see that there's 5 elements in the array and hence it ends at index location 4. So I start out and I is 1, so I'm going to look at index location 1 and we see that 30 is less than 80, so we update min to be 30. And we're at the end of the loop, so we now increment I to be 2. We now look at 50 and we see that 50 is, so let's just move this down here for a moment. We see that 50 is not less than min because 50 is greater than 30. So we increment I to be 3 and compare 70 with min. And again, 70 is greater than 30, so nothing happens. Increment I to be 4. And again, 90 is not less than 30. Increment I again and it's 5, and that takes us out of the loop. So you can see how the counter variable allowed us to iterate through all the elements and grades and allowed us to find the minimum value, which is 30. And just as an aside, you'll note that I didn't know how small my grades could be. I didn't say that they couldn't be a negative number. So a safe thing to do was to assign the first element in the array to min, because that is a known value in grades, and from there we could check the rest of the array to see if there were any values less than that first element. Okay, now a couple cautionary statements about arrays. First, please do not use a variable to declare the size of an array. So here's an example. I declare a variable called numDays and ask the user to enter the number of days and then read it, and then I declare an array of that size. This code's illegal on many compilers. Our lab machines will allow this usage. It's in the C++ standard, but many C++ compilers still do not support this idiom. Please do not get into the habit of using it. You should think of arrays as objects whose size you have to declare at compile time and not as something whose size you can determine at runtime. Now it is okay, you may be saying, well, wait a minute, you were using a constant variable. Well, that's different. If I had said here const int numDays and then given it a value like 20, then it would have been perfectly reasonable to use numDays there, but that's because the compiler knows when it compiles the program that numDays is equal to 20 and it can allocate an array of size 20. So it's perfectly fine to use constant variables. It's not okay to use variables whose value will not be determined at runtime or until runtime to declare the number of elements in an array. And the second thing you need to be careful about is indices that are out of range. Clearly, all negative numbers are out of range, but also positive numbers greater than the number of elements are out of range. And most importantly, indices equal to the size of the array are out of range. So if I try to assign 42 to num5 here, that memory doesn't belong to the num array because the indices only go from 0 to 4. And what's really nasty about this kind of error is the compiler won't give you an error message. However, it will clobber often, or often will clobber another variable in your program, and then your program will produce unexpected output. So An index out of range is a logical error, and it's very hard to find. If you're looking to understand what the problem is, here's a pictorial way of visualizing it. Let's say we have declared two variables, an array of size 5. So num has these 5 locations in memory. And then int I declared right after it, so we'll assume the compiler put I right after the num array. So now I assign 30 to I, and I has the value 30. And now I assign 42 to num5. And we just got through saying, well, num5 doesn't belong to the num array. In fact, the way C++ may well treat it is, oh, it goes to the next element after where num5 normally would be, which is where I is, and change the value of I to 42. And now we print out I, and you're amazed when it comes out as 42 rather than 30, and that's because of your index out of range error. Now, if you try this code on your computers, it may or may not print out 42 for I. Many compilers know this is a problem and actually assign an extra few spaces after an array and leave them blank. But it's really bad practice because the array really isn't that big, and some compilers aren't that forgiving. Okay. The final topic today is array initialization. You already saw an example where we assigned some values to a grade array. In general, you can initialize an array by giving it a comma-separated list of values enclosed in curly braces. And when you do so, it's not necessary to give the size of the array. If you do that, leave the size element blank, then the compiler will assume that the array should have the same number of elements as the number of elements in the initializer list. So in this case, grades would have 5 elements. And it's okay to have an initialization list where the size of the initialization list is less than the number of elements. In that case, the first elements of the array are assigned the values from the initialization list, and any leftover elements in the array are assigned what's called the base value of the data type. So for ints, the base value is 0. For strings, the base value is the empty string. So in this case, num2 would be set to 0, num0 would be set to 1, num1 would be set to 2, num2 would be set to 0. Now again, you don't need to use an initialization list. In fact, it's fairly rare to use initialization lists. Usually you're using arrays to store values that you're reading from user-supplied input, like the pixels in a photo or the temperatures from an observation station. Okay, and then a final thing is, while our system does initialize your leftover elements to 0 for ints or empty string for strings, you shouldn't rely on it. Not all compilers will do so. Also, if you do not provide an initializer list for an array, it's just like what happens with your variables. We technically say the array elements are undefined. So if I say int score 5, you should think of the elements of score as being undefined. You don't know what they are. Some compilers will set all 5 values to 0, but you should not rely on it.